Okay, so I guess the three of us that are presenting should probably introduce ourselves to start. I'm Duncan Silversides. I'm a alumni of Team 3491 Fix-It. I've also been helping out as a robot inspector at the local tournaments for many years now, and my family's also been very involved in the FIRST program over the years.
I'm Dorian. I was with Belmont Bites 12354, and now I'm just volunteering, roughing, and helping out with these.
And I'm Isla Simpson. I'm also an alumni of 3491 Fix-It, and I've been helping out with as many of the events as I'm in town for the last few years.
Yeah. So this workshop is kind of to cover the different parts that are both allowable and easy to use that don't come in your basic kit of parts. And so different ways of acquiring or looking for parts that aren't easy to get, or you don't want to buy a ton of new kits to get spare parts for your robots. Yeah. So
okay.
I guess one of the first things is kind of when you're looking at robots, often you end up wanting to have more channel of different lengths than what comes in the kit.
If Dorian stops sharing for a second, when you hold stuff up, it'll be more visible.
Right. I can also put up a background and show it in front of that. I don't know.
No, but you become full screen. If Dorian will stop sharing for a minute.
We can see.
I tried pausing the share. Did it let you see it?
I think I'm still in small screen.
And your screen share, Dorian.
I'll just stop it.
Now start talking, Duncan. I think you'll go big screen.
Anyway, so with the different types of channel, one of the easiest ways of getting more channel of varying lengths is to go and find pieces of aluminum tubing, square channel, that are easy to find at like Home Hardware or Home Depot. And you can get them in like 3 to 4 foot lengths and then cut them to the size that you want to use on your robot. It does require being able to use either a hacksaw or a bandsaw to cut it, and then also being able to drill into metal. But that's usually very easy with either a drill press or with someone who learns and gets some practice with being able to hand drill metal. Another useful and easy way is getting angle bar, which is basically just the same sort of thing. This allows you to get different thicknesses and different lengths of channel and beams and these sorts of things without having to buy a whole bunch of spare parts from new kits. You can also find some very interesting ones. So this here, I'll just try and get a little background so you can see it, is a very small, I believe it's actually a brass tubing. It was actually from a hobby shop. So this would be like looking at like a model train store, like model planes and RC cars and that sort of thing. It was used for that. And so this was actually used on a very light arm that was being controlled by a servo. And because of the size of it, it is very small and very light, but it does still have some structural strength. So you can find parts that you just can't easily acquire in a standard kit of parts. Is there anything, Isla or Dorian, that you want to add on to that?
I would add not to limit yourself to metal. There are very few instances when other materials have quite the structural properties of metal, but depending on what you're building, I've seen wood used on robots and different types of metals. So don't just limit yourself to needing to find steel, aluminum, or what you're expecting exactly. Brass isn't exactly a normal selection, but it's there too, and it works well.
Yeah, also, if anyone has any questions at any point, if they can post it in the chat, we will try and answer it as part of this. I'm trying to bring the chat up on my computer. Okay.
Yeah, I can see the chat, so I can keep an eye on that.
Same here.
Yes, we want to go into the next one. Do you want to discuss prototyping with different materials?
Sure. So prototyping is really nice because it allows you to practice with different shapes and experiment with exactly how things work. So one material that we've often used was cardboard. So here on your screen, you can see an example of a system for collecting balls that we tried prototyping with cardboard to see exactly what would let us, what shape we would need in order to work with these balls and not lose control of them and not have them get stuck anywhere, which was a problem. So in this case, we tried a few different methods out of cardboard because it's cheap, easy to find, you can duct tape it together without too much fuss, cut it however you need, no special materials are needed, it doesn't take a lot of time to put something together and at least test a shape. Once you have a shape that you know works, then you can go on and make it out of whatever material you're planning to use.
Yeah, no, and it is a very useful way of doing that. You can also do it with wood as well. Depending if you have access to like a laser cutter, you can laser cut wood very quickly. And so that is another way of prototyping, is to use wood, and then you can, if you have access to that sort of, to a laser cutter or other ways like that, you can then laser cut wood to do it. I'll just show a quick thing on the screen here. So this is a piece of laser cut wood, and you end up with, I'm not sure you can see, there's a hole pattern on this end here. So that allowed this to be attached directly to a servo. And then if you, once you've end up making this, and if you actually like the way it looks and its functionality, you can then choose to make it out of, as I said, a different material, either plastic or metal, based on the materials you have access to.
And sometimes wood makes a good final material as well.
Yes, Lego. Do you want to talk about that, Isla, or do you want me to talk about prototyping with Lego?
I think this is your area of expertise.
A little bit. So you can actually see the on the left-hand side of your screen where there's some tires going into a tube. I actually have that tube kind of sitting here. Lego is a great way to very quickly build something and then test it to see if it could work. Very rarely would I recommend using Lego as your final product on your robot, but it is a great way to quickly build something to test. We even have, we built many things out of Lego over the years. This is a Lego Lazy Susan, so it's literally a Lego platform that was then used to have a gear spin on it, on the Lego wheels. You can build just a lot of the, certainly for some of the FTC teams, they have kids who have built with Lego their entire lives. So they built with it growing up, and so it is very comfortable and easy to quickly put together an idea and a shape with Lego. And so that is a great way to prototype and, as I said, test an idea to see if it could work. And then you can go back and actually make it using your prototype out of a material that will actually structurally last through the rigors of a competition.
One more thing to add, you'll note that this mechanism you see on the left here, it continues to have Lego parts as well as metal ones. they can wear each other down quite quickly. But in this case, we actually kept a lot of Lego parts on the actual design because this was at the end of an arm and the plastic was structural enough to be able to do what we needed while at the same time being lightweight. So it reduced the stress we were putting on our motors and our servos.
Yeah, that is very true. You do have to be very careful though when you are using Lego and metal in combined, because the metal will wear through the Lego and you will end up breaking many Lego pieces over the years, as I have done when you start testing it that way. You will very often find that you break several pieces of Lego. So do keep that in mind if you start actually testing it or putting it on a robot. Right, plastics. Do you want to start with Petchy, or do you want me to go through Petchy, Isla?
How about you cover Petchy? I think I've got a bit of a stronger handle on acrylics.
Okay. So Petchy is, I think it's technically an acronym, PETG, but anyway, we just call it Petchy. It is one of my favorite plastics to work with, mainly because it is very easy to work with. So you can cut it with a pair of tin snips. So it is very fast to create, to cut it to the correct shape you want. And then it is also very easy to heat gun, which allows you to form it into a lot of shapes. So you can take.
Yes.
I think someone has a speaker on, their microphone
on. How so? Like
Okay.
it scans if the ball made it to a certain position and give them.
Anyway, so for Petchy, it is very easy to heat gun into various shapes.
Well,
you can create.
Well, each of the 18 holes, you can have one of these. Each of the 18 holes can have one of these. It can detect
Can everyone
whether or
make
not
sure their microphones are
the gate
off?
has been tripped. And at each one, it can dispense like dried beans or
Javier,
gummy
you
bears
have your
or
microphone on.
whatever is appropriate for the season. Yes, probably canned.
Hey, forces unknown.
I know.
Thank you, Christine.
Anyway, getting back to Petchy, it is very easy to form it into various shapes using a heat gun. That is something that I would very much recommend that you have one of your team members or two learn how to work with a heat gun and plastic, be able to form various shapes that are not just straight sheets. As you get more creative with it, you can make all sorts of different shapes, from square boxes to very elaborate tubing systems, as you saw. This is actually one sheet of Petchy that was then formed into a circle. So it is a very malleable material that allows you to make a lot of different shapes, which you wouldn't normally, that I find it's very hard to replicate with the standard kit of parts. Yeah, so I would definitely just recommend that you have someone, one or two team members experiment with forming plastics, and Petchy is one of the easiest ones to work with. It is also very thin, so it is something to be remembered that it isn't a highly structural, or it isn't a something that would be able to replace like a metal channel as in terms of structure. So you want to keep that in mind when you're working with it, that it is a thinner plastic, and so it can bend and it can break. Isla, do you have anything to add to that for Petchy?
No, I think that's a pretty good explanation.
Okay.
Some other plastics that you can use would be polycarbonate, ABS, acrylic, UMHW, and these all have different properties and different uses. So for example, I believe it's acrylic, but it's been a while. If you try to cut it, you'll find you need something like a scroll saw with a bit of power. However, it will create enough heat to melt the plastic behind you as you're cutting it if you're not careful. So It's a bit stronger, a bit more structural, but it does have a very low melting point, which is good to know.
One more thing about acrylic is that it also is very easy to shatter.
Yeah.
On impact.
Unless you're careful.
The easiest way, if you are choosing to work with acrylic, is to use a laser laser cutter, and actually cut it using that. That is by far the best way to cut it. And you can also etch stuff into a side panel that way.
Does that still have the lights on it?
Not currently, no, but because it's just the side panel. But you can also light them with LED lights if you want to make it look more interesting. One of the other, I think it was ABS was on that list. That's what this black sheet is made out of. It is one of my favorite materials to work with because it is slightly softer than polycarbonate. So drilling it, it drills much easier. You don't have as much difficulty with hand drilling. You also can cut it with a multitude of different ways. Depending on the thickness, if it's a thinner sheet, you can cut it with tin snips even, but it is quite easy to hacksaw, and you can also jigsaw with it without having it melt. And it also is quite easy to heat gun. So it is one of the a very nice all-purpose plastic to use. And is one of the most forgiving in terms of not shattering on you.
Yeah, so for anyone thinking where might they use these, you'll notice frequently that Fix-It uses them for side panels because they can get scuffed up and scratched by other robots without damaging anything inside of them. So they're great for protecting electronics, wheels, and just generally keeping things away from your robot.
Oh, the other thing that Fix-It has historically used plastics for is to mount all of your electronics on them and then put it to the side. So like if you have a side panel, you can then put a plastic sheet and then mount all your electronics and just in empty space on the side of your robot somewhere. Or underneath your robot and then put a shield underneath that.
Just make sure you cover your electronics and don't leave them vulnerable, please.
Yes, never.
Especially the phone.
Yeah, you don't want to leave your electronics open to be hit by other robots. I will always remember the time I saw a robot get turned off by another robot because their power switch was mounted on the outside of the robot. They hit each other and it turned one of the robots off. So always keep that in mind when you're putting electronics, power switches, main electronic cables that are core systems of your robot. Make sure that they are not easily accessible to either the walls, the playing field elements, or other robots. The other thing to keep in mind with your power switches is don't put them on the very top of your robot because any robot with an arm that comes down on them can turn your robot off. So make sure to keep location of your power switch is one of those minor pet peeves of mine. When I see them and I'm like, make sure that it isn't easily turned off by things other than a human being.
It's a fine line.
Yeah. Polycarbonate is one of. I just want to talk a bit about polycarbonate. It is often what you find in easier to find in thicker pieces of plastic, and so it is much more easy to use as a structural plastic. And so you can use it in replacement for metal sheets in certain cases. So it is definitely it's definitely one of those materials that if you need a very odd shape to be structurally sound, but you don't have access to a machine shop to make a metal piece out of it, it is very nice to be able to use something like a thick sheet of polycarbonate, and then you can create a odd shape out of that, and know that it will be structurally sound and it's not likely to break on you. Oh, another thing to just with plastics, sometimes you can use bandsaws and that sort of thing. One of the things that our team has used over the years a lot is a handheld jigsaw, or hacksaws. Those are the two primary ways that we cut a lot of our plastics. And so having a couple of team members who know how to use those tools safely as well as how to easily cut those sorts of materials.
And just to add to that, especially when using tin snips and cutting plastic, you may not think you need safety glasses. It does go flying and it is sharp. It is deceptively nice material. It looks nice. It looks like it'll be fine. And then you snip it and polycarbonate, you cut it and it shatters and it flies towards your eyes. Or plastic, you cut it and it has just enough force built up in it that it bounces back and hits something. Just please don't be fooled.
The other thing to remember when you are cutting plastic with either a hacksaw, tin snips, jigsaw, whatever you're cutting it with, the edges you leave behind after it's cut are sharp. I don't know how many times I got what we used to call robot bites, where you would get a little pinprick or what amounts to a paper cut on your hands from jagged pieces of plastic. Hence why there is a lot of tape on this piece here at the joins, because these were sharp. And so we used packing tape on the edges of plastic so we didn't have to file the entire length of everything. We just put a piece of tape over it to keep these sharp bits from cutting your fingers.
And if you're doing your own manufacturing of parts with metal, plastic, whatever, anything you cut will be sharp. So tape is a really good thing to use all the time and always to keep with you. You may not notice it's sharp, but you'll notice the robot inspectors always run their hands over your robot to make sure that anything that looks sharp and pointy isn't. That's not really something you have to deal with if you're just using the kit parts, because they're all rounded. But if you start manufacturing your own parts, it's something to watch out for.
Yeah, you either want to have someone who's very good at filing and is willing to spend a amount of time to file all of the round and sharp edges, or it is much quicker to just use some either packing tape or gaffer tape. We'll get to a little more on gaffer tape later. But those are the two tapes we generally use. Duct tape is not something you generally want to use because of the amount of residue it leaves behind.
We were talking about earlier getting polycarbonate and Lexan, and buying new sheets of polycarbonate and like other plastics can be very expensive. So it might be extremely helpful, as Duncan was showing maybe a little bit before this meeting started, about getting some like used polycarbonate with leftover materials on it. So as you can see, I'll let him talk so you can show us up.
This is a piece of scrap that we got from, I want to say it was Industrial Plastics, but going to a plastic manufacturing, a machine shop and asking for their scraps, scrap metal, scrap plastics, or any other form of hardware store / manufacturing shop. Often if you talk to a store like that, maybe they don't want to sponsor your team, but they might give you a discount on scrap materials or even just give them to you for free. So that is something where some companies that won't sponsor you with money might give you materials instead. And also looking through scrap bins at different stores, the cutoffs and that sort of things for wood, metal, plastic. That's how we got a lot of our materials kind of collected over the years, was just someone found something in a scrap bin and it was like, oh, this looks useful. And so as you saw when I was holding this big sheet, if you want to build a big sheet of plastic, it might not be great, but if you cut it off, you suddenly have a small chunk of plastic that could be very useful for making a small, cut it in half and you make 2 V's for like a plow guard or something on the front of your robot, or some other sort of shield for the electronics or the phone or something. So yeah, definitely try and get creative with having your team members on the lookout for different materials or and as I said, talking to manufacturing companies about either sponsoring with materials as opposed to money, or being able to purchase scraps and cutoffs from various companies.
Just one more thing to add to that. If you're getting your plastic from somewhere and you don't know exactly what kind it is, it's really good idea to figure it out. As we were talking about, the different plastics have different properties. So if you have something that you think is polycarbonate and you start cutting it and it shatters, that can be really annoying, and that can mean you've just lost a good piece of plastic. So there are little things you can do to figure out generally what you might be working with. So that way you don't destroy something or try to use a heat gun on something that just proceeds to melt into a useless blob.
Yeah, no, definitely. I have to say, acrylic is probably the most unforgiving type if you're working with hand tools. So you do want to identify if you have any pieces of acrylic, and then only use those in very specific circumstances. Whereas something like ABS can be used on just about any form of cutting material and is very forgiving. Other ones are very unforgiving. So definitely, we actually walked around. I'm not sure if we have any. I don't think we have any sitting beside me right now. We got little stickers. They would go, or use a Sharpie, and we just put ABS, acrylic, polycarbonate, PETG on our different pieces of plastics to identify what is the plastic that is sitting there, so that when team members go to look for plastics, they know what they're picking up. Yeah. Oh, one thing I just wanted to briefly cover while we're talking about plastics is kind of attaching different plastics to things. So this is just a cup thing that I want to get a little background for this. But if you can see, this is kind of like a cup with sides on it. Oh yeah, and just for holding some stuff. But this was actually attached not by using screws, heat gun, or gluing or anything, which are all viable ways of attaching, but these were just made with some holes and a few zap straps. And these are now attached very solidly. It is worthwhile to know that plastic can be attached kind of like this if you, using zap straps to attach plastics is a great way to either just straight up attach it or to be able to make hinges and that sort of thing. We often did that on our side panels with electronics and stuff, where we would often put zap straps on two holes on one side and then a screw on the other, so you only had to take one screw off and you could pull an entire side panel away from the robot on a hinge. Right, random stuff from hardware stores. Dorian, do you want to talk about that a bit, or do you want me to keep going?
Absolutely, I can talk about this.
Yeah.
Hardware stores actually have a surprising amount of hardware, but for example, a lot of those kits that come with the first tech challenge, like full assembly kits, have maybe one size of lock nuts or bolts. Hardware stores will have bigger, longer bolts, bigger nuts, different types of nuts. So in case maybe a lock nut's a bit overkill for what you're doing, you can find just generic nuts, washers, all those generic hardware for pretty cheap, just like cents for a lot of the hardware. They also have like zap straps, Velcro straps, and so many. I'll quickly stop sharing so you can see Duncan.
These are just Velcro zap straps. I'm not sure how many people have heard of them, but they are very useful. Basically, they are Velcro in a zap strap shape. I'm just trying to see if I can get it easily viewable. But it allows you to just kind of use a zap strap, and then it's basically a reusable zap strap. It is great. For one of our favorite uses for them is to tuck wires away. So you find a clump of wires and you just put this around it. And then if you have to move them, you can just take it off and then put it back.
That's really helpful for like prototyping and testing like different setups for where you want your maybe your wires to be located. Because I've had several experiences where I've used actual zap straps while like testing, realized we needed to move them, and you have to cut the zap straps, then re-get new ones out.
The other
So it
thing
can
is,
save you a bit of zap straps.
the other thing is if you have a wire that is like dangling down in front of a wheel, you can just very quickly, as you're like, if the programmers want to keep working, you can just tie the wire up with a Velcro zap strap, and then you can actually properly wire it later. It helps a lot with keeping wires out of places they shouldn't be.
It's also just good for like reducing amount of waste when you're trying to build your robot every year.
Yeah.
You can reuse those. You can't really reuse zap straps once you cut them. Next up, threaded rod, and as we were talking about earlier, all these angle metals. There is a large amount of different shapes, size, lengths, thickness of metals, and threaded rod. The threaded rod, they have like just the generic bullets. They'll have just threaded rod of like various lengths up to like 4 feet, which you probably would need to cut them for different uses, but then you can get exactly the lengths you want. In those cases, as we discussed earlier, you want to make sure you don't have any of the sharp edges left, especially with cutting metal with a hacksaw or whatever you're using. They have tons of different just sheets of aluminum, sheets of obviously like the polycarbonate and Lexan and acrylic. And then as well, smaller pre-built like hinges, joints, connections that you could be using as long as they meet the requirements for the competition. And as well, pipes, PVC, tubing, heavier pipes. You can cut down to different lengths, which can be used for maybe like picking up balls or maybe just holding things in place.
One of the big things we use the pipes for is we cut them into lengths roughly the size of like a little piece of PVC or something, and they were solid steel, and we use them as weights on our robot as counterbalance. And so you could stick them into a Tetrix U channel and then zap strap them in place, and suddenly you have a half-pound weight on a piece of your robot. So it was very useful when we had arms on a robot to counterbalance them, so it didn't flip the robot over.
Small pieces of solid iron are surprisingly heavy when you have like chunks of it, and it can be used to balance your robot out, especially if you accidentally make a top-heavy robot. Yeah.
One thing to remember when you have large pieces and stuff like that, or any form of pieces like that, is you can get, sometimes, depending on the hardware store, they have cutting shops in them where they will actually cut stuff to length for you. So if you know that you only want 14-inch lengths of this like bar or whatever, you can often get them cut to size at the shop you're buying them from. Or if you have access to like a bandsaw at like in, well, I don't know, depending on if you have access to a machine shop or something. I don't know. It's just one of those things, like if you, certainly depending on the store you go to, you can get some of your materials cut to length ahead of time if you actually plan ahead as to what materials you're buying.
Yeah, it really helps when you're doing things like that to know what you need before you go and buy it, because sometimes you might see like a 3-foot rod of aluminum. It might be half the price of the 4-foot, but then you realize you need the 4-foot, which I don't know why you need 4 feet, but
if you needed like 4 12-foot length, like 12-inch segments or something for some weird reason.
Yeah.
Other things hardware stores have, and other stores, like things like drawer slides. I'm not super familiar with the phrase COTS, so if maybe Allie or Duncan, you want to expand on that?
Yeah.
Consumer off the shelf, I believe, is what the definition is. So it's basically stuff that you can buy that has motion in them, but is pre-manufactured. You're only allowed to use COTS that have 1 degree of freedom. So things like Lazy Susans, drawer slides, they can't be stuff that has multiple degrees of freedom. So while it can like extend in one direction or it can rotate, it can't do both.
Yeah, so yeah, as we were talking earlier, you can get these at most hardware stores or cabinet stores. And as I was talking, like hinges and stuff kind of fall into the same category, just off-the-shelf things that have degrees of freedom. These are surprisingly cheap and they're really smooth. So if you want to have a really well-structured mechanism that you need to have some sort of linear motion, this can maybe save you the hassle of trying to build it yourself.
It is very much cheaper to get like drawer slides such as the one here, and then use it versus, we'll just switch in there. And so you can raise stuff up on string in that way. It is about like, it can be as cheap as like 1/10 the cost of getting linear slides to get just a drawer slide. And you can find them in various shapes and sizes because it's all sorts of things from like kitchen cabinet drawers to any form of drawer slide there are many different styles, and so you can find several that are very useful. And as you were saying, they are much smoother and easier to work with than the linear slides you buy in the kits. I don't know how many times I've tried to put those together and I can never get them to work properly. I just connect some drawer slides together and it works almost the first time.
Yeah, drawer slides have mounting positions for them, so you're supposed to just screw them into like cabinets or the wall or whatever it is. But then that could just be used for the bolts with like lock nuts. It just fasten them tightly into place. It's just seconds to throw on sometimes.
And if you have someone who knows how to use a drill on metal or a drill press or whatever to drill metal, you can drill holes in the shape of the channel that you're using, be that Robotics or Tetrix or whatever other pieces you're using. So that way you can create a custom hole pattern where there might not currently be one.
Alternatively, you can also just get a sheet of plastic or metal and just drill the holes that you need that way. It depends on whether you have a team member that is that skilled at drilling to be able to drill out a hole pattern. There have been times where that has been a challenge. I'm not sure if we have.
I'm going to put something in just before we keep going here. It was mentioned briefly, but you do need to remember as we're getting into the more complicated COTS parts that you can purchase, 1 degree of freedom means 1 degree of freedom. So while you can build something using multiple pieces that each have 1 degree of freedom to make something with multiple, you cannot use any pre-purchased parts with more than 1 degree of freedom.
I will say that the Lazy Susan that you see on your screen currently is by far the easiest way I've seen for making an arm that is actually controllable. So what you do is you take one of the big gears that you get from the kits and you drill out the center a little bit, and you can or you drill it out so that it attaches to the Lazy Susan, and then you can feed your wires straight through that hole in the middle. And that way when you have an arm that's swinging back and forth, your wires don't get twisted. It also allows for a very smooth rotational mounting platform that is actually very stable. Lazy Susans are also extremely cheap. Right. Isla, do you want to talk about PVC?
Sure. So PVC pipe, plastic, circular, so it has some amount of structural integrity to it, as well as being very easy to work with. So we will frequently drill into the side of it and use surgical tubing, which is like a rubbery tube that you can also purchase at most hardware stores to make an intake. So we have that spin on a servo or a motor, depending on how much torque it needs. And that can pull in components, which is not really illustrated in this picture, but I think we might have a picture of Fermion later that has a really good intake picture, so you can see the use of PVC pipe. And larger diameter, can get game pieces going through it, depending on the size of the game piece, obviously. But yeah, really easy to work with. And as Duncan mentioned earlier, you can always find other types of pipe and use them as counterweights. I think we used to use PVC pipe filled up with bolts.
That was before we got access to the metal pipes.
Okay.
We used to fill up a PVC pipe with nuts and bolts that were spare to create weights. But that was back when there was more restrictions on what parts you were allowed to use. In the previous picture, you saw that there was tons of holes on that big piece of PVC pipe. That was actually done to lighten the weight of that piece of PVC, because it took 2 DC motors originally on the large piece of PVC, and it started swinging around with a lot of weight, and it smacked into the ground so hard at one competition that it dented the mat slightly, and we got a warning to not damage the playing field at one of our leagues that year. So we ended up cutting it down to a smaller size, and then Alex spent a long time drilling out all of the holes there to lighten the PVC so we could be more controllable with that piece. So it is something to consider. The weight on PVC does add up. when working with it. It is also one of the more expensive plastic materials, so do keep that in mind. Unless you have it kicking around your house from various other things, it can be somewhat expensive to purchase. You may want to like see if you actually want to use a lot of PVC. You could try and talk to like a plumber to see if they have scrap pieces or something. Oh, unless someone specifically wants to talk about wiring, I'll talk about this piece if that's
I like
okay.
talking about wires.
Okay, if you want to. Yeah, go ahead.
Yeah, okay, so there are a number of things on your robot that you're going to need to wire up, and it's nice to put a little bit of thought into how you're going to do it so you don't end up trying to run a wire through a couple of gears and end up getting it crushed up and eaten. So servo extension cables are your friend. They will let you, they'll give you a bit more length in the wire so you can route them where they need to go. Clear plastic tubes can help keep wires away from things. And zap straps or zip ties are very good for keeping wires where they're supposed to be and out of the way of anything that's moving. Again, it's really nice to put a little bit of thought into things like your power switch. Where is that going to go so that it doesn't get in the way of all your other mechanisms and there's no chance it's going to get hit? Where's your phone going to go so that it doesn't end up being dragged behind by the USB cable? Done that. It's nice to take a piece of plastic and mount all of your electrical components onto it so you can zip tie down the wires initially and just keep most of the electronics out of the way. So then all you have to worry about is the wire routings throughout the robot. Power cables and servo cables, sorry, you're going to want to keep them a little bit separate because some of the electromagnetic forces from the power cables might interfere with your servo cables if you keep them too close and they're not shielded. So that's just something to note.
Yeah, so just a couple more things with wiring. When we talk about clear plastic tubing, this is what we had. It's kind of a tube that we could just cut with a pair of scissors to a length. And it was in a scrap pile somewhere. But having something like this where you can just feed some wires through it, and you can still see the wires, which is also very useful because then you can track it. Where is that wire going? The other thing that we often used to do is when we had those servo extension wires, we would actually use zip ties and zip tie the two wire pieces together so they couldn't come apart.
One more thing, when you add a servo extension wire or when you wire anything on the robot, label both ends, the start of the wire and the end of the wire, so that way no one has to go tracing wires in the future because that job sucks.
Yes, it is very useful. Actually, it's one of the main uses that we use for white gaffer tape is we just put a little piece of tape around the end of the wire, and then we would write with a Sharpie what is on the other end of it. Is it the left drive motor? Is it the right drive motor? Is it the arm? Is it the grabber piece? It is very, very useful to label your wires. And then also electrical tape is also your friend here to be able to tape wires together or identify, because if you have different colors of electrical tape, you can just identify by different colors of tape.
I'm sure most people here are pretty mechanically minded, but this is also a nice thing to do for the people on your team who are programming, because then they don't have to go once you've left and try to figure out what wire is going where, because the entire robot is built and wired up now, and they have to label and make the configuration file to label what wire goes where. So even if you think you'll remember where stuff goes, your programmer doesn't necessarily have your brain.
It also means that you don't technically have to make a wiring diagram of your robot. I'm not sure if all teams do that, but if you properly label everything, it does make things much simpler for everyone to work on your team, to just be able to very quickly understand. You actually see in the photo that's currently up there, there's tape on the motors on the front there, which say left and right. which is just taped onto the motors so that people know where they are wired to. You can label the wires, you can label the motors, but label places on your robot. Also, it is very helpful to decide as a team, with both the builders and programmers present, which is the front and which is the back of your robot. If the builders think one way is front and the programmers think the other way is front, you end up with some very interesting confusion as to which is the left and right side of the robot and where are things mounted and where is everything going.
If I remember correctly, those pieces of tape saying left and right there are because we couldn't agree which side was the front. So we were building one side to be the front and have left and right motors, and the other side was getting programmed to be the front. So about halfway through, we realized this was going on, and someone labeled the motors, and things didn't change after that.
Yeah, it does help with deciding those sorts of problems. Making sure that you know which way is front on your robot can be a very important thing when you're communicating.
There is a front.
Yeah, so if you want to go to the next part. Yeah, so one of the other big things for wiring, always make sure that your robot can be flipped onto at least one other side than its wheels. So you can access the underside of your robot, so that you can get access to the motors that are down there. If you actually have your electronics down there, potentially, it is very, very useful to be able to flip your robot onto one other side than its wheels. Dorian, do you know about compliant wheels, or?
I'm not super familiar with compliant wheels.
Same for you, Isla, or?
I know a fair bit about them. Although they're not actually in this picture, so.
The Andy Mark compliant wheels are over on the left.
Yeah. No, the ones on the left there are compliant wheels, which basically means they're designed to bend around whatever's they're pushed up against. This is great when you need to have a little bit of a grip on something, because while the rubber will will hold on to it a little bit, if there's also a bit of pressure pushing in from either side, then it's much easier to hold something that might be a little heavier, or to be able to lift and carry things that aren't necessarily, that are made of a slippery material. So in this case, you'll see that we were trying to pick up a couple of foam cubes. So we didn't use compliant wheels, but in another year we did use them, I believe, on plastic blocks that were rather slippery. Yeah, the ones Duncan's holding up right now.
The other thing that you can use, so that system, which is actually I think it's a pair of 3-inch Tetrix wheels, they then have Lego tire treads strapped onto the edge of them to give them more grip. That is a very easy and much cheaper way, if you can't easily purchase compliant wheels, to create wheels that have a lot of grip on them.
Also taking your Tetrix wheels and wrapping them in some sort of a foam if you don't have Lego tires, or something that is squishy.
You can also get what is called grip pad, but basically it's often used in kitchens and stuff as mats and stuff. So this, it is a very gripping material, and you can strap it onto wheels or other surfaces to increase grip. So you could put it onto pincers if you're grabbing something. There's a lot of different ways that you can use grip pad. It is very useful to have a few pieces of it lying around in case you need to create something that just has a little more traction. Or you create a mechanism that is trying to grab for a collector or something, and then you find that it just doesn't quite have enough friction or traction. You can just use the grip pad to get a little bit more.
Yeah, so I guess when it comes down to looking for parts, it's just really about being creative. They are in places that you would never expect, and if you would just keep your eyes out for random parts when you're just living your life, it really becomes helpful. Some examples that we have is like Rover Ruckus, that mechanism right, or the ladders right in the middle, have a ton of scrap parts, and if you aren't rebuilding that game field, you could repurpose those parts for future robots. As Duncan mentioned earlier, manufacturing companies can potentially donate or give you guys random scraps or parts that you might need, especially when it comes to like just things that are way too small for them to use, but might be perfect size for maybe making it work for a part of your robot. And yeah, like marine supply stores, sailing string, Duncan was showing me a little while earlier, so see if he has that still.
Yeah. So this is just a, I'm not sure if you can easily see the string itself, but it's just a piece of sailing string. What's special about sailing string is that it doesn't stretch. So when you're using it on a scissor lift or some other mechanism that requires string to move, it is very useful to have a string that doesn't stretch, because then if you need a certain tension, you know that it isn't going to change. The other thing you can get from scuba stores and stuff like that, this is actually, I think it's, what is it, scuba? Yeah, it's hose for scuba diving. And so it works as a surgical tubing to create a stretchy band. It is basically a substitute for surgical tubing, which you can also find different materials from like hospital stuff. So you have surgical tubing or gurney wheels. If you want to go over one more slide, Dorian. Those are actually surgical gurney wheels that were 5 inches and had more grip than the regular Tetrix tires. And although they didn't have, you'll notice the 2 Tetrix plates there. We actually had to create our own mounting bracket for those wheels, because the center of them were just free spinning, and so we ended up drilling the holes to attach the Tetrix plates to them to create a system that would actually attach to Tetrix parts. But that is looking at different types of wheels can, from various places, can give you more options than what are just given in the basic kits.
I actually believe those gurney wheels came from a hobbyist store. Pretty sure I remember getting them at BC Shavers and Hobbies the same time we got that brass piece.
I think it was Western Equipment, actually.
Okay.
There's a bunch of different sources and places you can get stuff from. Yeah. It is always worth poking around in various shops to see what you can find.
Just as a fun note, those tires actually ended up being too grippy, so we covered a couple in duct tape to reduce the amount of friction.
Yeah, so these are just wire scratchers that are used, or what are these? Hair scratchers. And they were used to pick up balls. Yeah, you can get really creative. These are actually 2 of them that are connected together at the tips with little pieces of wires. Yeah, it's always useful for, if you have team members there, to just get creative and try and figure out odd solutions to things.
Dorian, you should read out the comment from the chat.
Oh.
Yeah, so the comment there was just Javier from Forces Unknown commenting on where we got the hospital wheels, and if we were looting them from abandoned hospitals. I say we, but the Fix-It team, I guess, when that was happening.
Yes, that would be no, but this was, I want to say, this was several years ago when they were sourced.
2015.
Yeah. That's quicker memory than I had, Isla, for when we got those.
It was my first year on the team.
Yeah, which is why you would remember versus, I think that was my
last year.
Was that my last year? Yeah, anyway.
No. Oh, wait, yeah, it was, because I was on the team for, that was your last year.
Anyway, if you want to go on to the next slide. Yeah, so as we talked about earlier, gaffer tape is one of the really useful materials to create things because it doesn't leave a residue. So you can create, like, this is literally a Tetrix axle that then has grip pad and zap straps onto the axle so that it actually grips the axle. and then it's just covered in gaffer tape to create paddles for a collector. And so gaffer tape can be used in a lot of different ways, from wiring to keeping plastics or metal bits from being too sharp, to also actually like structural material. If you have to, let's say you're at a tournament and something goes wrong, you can actually tape on a side panel. It is very useful to have a roll of gaffer tape kicking around for a lot of different uses. I think the next one is Isla's to talk about, yeah.
Yes, okay, so this is Fermion. Fermion had a lot of things that we went and bought from a hardware store. I actually made a list here. And there are definitely a few of them listed here on the screen as well. So we'll go through just how many things on here we decided to make ourselves because we couldn't find pieces. So you'll note the surgical tubing there is used as an intake. So that worked quite well because we kept it under tension, and the two white bars you see on the top and bottom of the surgical tubing are PVC pipe. So yeah, Duncan's showing them off right now. We drilled holes in them, I believe. Or we did something to make sure that they would stay, the surgical tubing would stay where it was supposed to be. We might have put it between bolts or something, but
yeah.
the idea was basically so it wouldn't move left to right. Yeah. And then a cardboard ramp. So yeah, the ramp, you can't see it in this picture, but where the balls go up between the surgical tubing and the rest of the robot was cardboard. I think we ended up making that out of PETG later in the season. So uses of plastic there. It was an interesting shape, but we used cardboard to prototype it. Square channels, what does that say? Green bars. Yeah, so the square channels we used here on the shooter in the center, which you'll see is kind of that half circle thing. So that was made up of a lot of store-bought parts, 3D printed cap to hit the ball, plastic that we used to make kind of an aiming mechanism, the green bars to hold it in place, a spring that we got from a hardware store that is very strong, so that way we could set it up and have it be ready to fire and then fire it exactly when we wanted to. Made it very nice and precise. We also ground off half of a gear so that we could make a mechanism that would basically move to one point and be ready to fire and then move just a couple clicks further and it would fire because it would let go of the spring.
Also, the firing pin was made out of a plastic rod that got picked up from a hardware store.
Mm-hmm. Yeah, you'll note also the 3D printed phone case, the Mecanum wheels, which we purchased. And if you look down there at our drive base, on the outside of the Mecanum wheels, that thin green bar is the brass bar that Duncan held up earlier. These tall vertical gray bars in the foreground here are 80/20, which we use to make a lift, kind of a waterfall design. So those were also picked up from a hardware store, and all of the pulleys on there were, maybe went through a couple different pulley designs to try and find something that worked. So we bought some at a hardware store, we bought some online, we 3D printed some. I don't remember which ones we stuck with. I think it was ones we bought at the hardware store. For years we've been using lock nuts and kept nuts that we bought at the hardware store because there are never enough in the kits that you get. Also on the opposite side, that black panel you see is a plastic panel that our electronics are mounted to. And on the outside was that acrylic panel that Duncan showed at the beginning that had all of our sponsors etched into it. And it had a set of lights at the bottom that lit it up so that there was quite a difference between the unetched portion and the etched portion, which looked really, really cool. Yeah, so that's it. And that had a hinge to swing off so that we could access the electronics. And I think that's everything. But yeah, a lot of this is stuff that did not come in the kit.
But we still used the Tetrix kit to build the drive base and the frame mostly.
It's still the majority of the robot.
And so you use these as supplementary parts to add on to your robot to enhance it or make things that would not otherwise be easily possible with the standard kit. Yes.
I think
I think
at the end of this, I'll go for it.
I think just before we end, are there any more questions from the chat? If anyone has any questions about this, if there's anything they want us to answer while we're all still here.
Christine says, register for next week's session on game rules with the BC head referee. There is a link in the chat for anyone looking to access it. And a reminder, the link will be sent to participants on the day of the workshop. But there are no more questions.
Yeah. So I guess I will just say thanks to the two of you for coming out and helping with this. And it's been fun.
And thank you to everyone who came out and gave us someone to talk to.
Yeah, I hope you guys found something helpful out of here.
Thank you very much. That's very helpful for the new teams. Thank you very much. I appreciate your efforts.
Yes, and I believe this will be posted on YouTube at a later date. What channel would that be? Would that
It'll
be?
on the
So it'll be posted on the first BC YouTube channel. Not entirely sure when that's getting posted, but hopefully in the next week or so. So if anyone wants to review it, or if you want to have any of your team members, for any of the coaches or other people to go and review this to get some ideas on where to source parts at a later time.